Moving right along, here's page 3 of your chapter 10 study guide tutorial video. So 17, 18, and 19 are solving systems of inequalities. Main difference between these types of systems and ones that you've done previous to this chapter is that these systems include our conic sections. Now, this first one for number 17, y is less than or equal to 3x minus 2, that one actually is just linear, right? It's got the x exponent is just 1, and it's already in slope-intercept form. So my y-intercept is -2, so I can graph that first. Slope is 3, so I can count up 3 and over 1. It's less than or equal to, so I can just go ahead and make that a solid line. And then before I move on to the next inequality, the main pieces to these questions are test points. So I want to pick a test point. Again, you can choose any if possible. I always recommend 0, 0. The only ones you can't choose are if they are on the line itself. So like we could not choose the point 1, 1 because that's on the line. So if I test the point 0, 0 for that inequality, I get 0 is less than or equal to 0 minus 2, which is 0 is less than or equal to -2. This is false. Since this is false and 0, 0 is on the left side of that line, I know that I'm going to need to shade on the right side of that line, which I'll save for last. Okay, my second inequality is x squared plus y squared is less than or equal to, or less than, sorry, 16. So if it's less than 16, this is the equation of a circle. There's no h and k movement, so I know that the circle has a center point at the origin. And I know that if r squared is 16, then the radius of that circle is 4. So then I can graph up 4, left 4, down 4, and right 4. And this is where things get a little bit interesting. Since it's just a less than 16, that means our circle has to be a dashed curve. And just like we did for the line, we have to test a point for the circle as well. Even though 0, 0 is the center point of that circle, technically the center point is not on the circle, so you can test that point. So if I test 0, 0, I get 0 squared plus 0 squared, which is just 0, is less than 16. Since this is a true statement, and the point 0, 0 is inside of that circle, I need to shade where that point is, which is on the inside. So if I shade on the right side of the line, but the inside of the circle, those areas will overlap in this space here. Number 18, I've got y is less than or equal to x, which is also just a linear inequality. It goes to the origin and it's got a slope of 1. It is less than or equal to, so it is going to be a solid line, basically is a diagonal through the graph. And we need to choose a test point. We cannot choose 0, 0 or 1, 1 for that matter, because those points are on the line. So I'm going to choose the point 1, 0. So I'm going to plug in 1 for x, 0 for y. So if I do that, then I get 0 is less than or equal to 1, which is true. So if that's true, I want to shade on top of that line, which is going to be on the right side of that line. Which seems weird, but I'm just mentally double checking that before I move on. Right, that's the x, that's the y. So if x is 1 and y is 0, 0 is less than or equal to 1, which is true, so I'm shading the right side. All right. Anywho, next inequality, y is greater than or equal to -2x squared plus 4. Okay, that is a parabola because it has one squared term. Now, the parabolas, I think, are honestly the most just tedious to graph because I want you to graph the vertex, the focus, the directrix, and the axis of symmetry. Okay, in doing so, we need to get this parabola into standard form. So in doing so, I want to go ahead and get my x squared terms to one side and everything else on the other side. So I'm going to subtract 4 from both sides. So I'm going to get y minus 4 is greater than or equal to -2x squared. And then to get my x squared term alone, I'm going to go ahead and divide everything by -2. Now, I'm going to keep this y minus 4 together. And when I divide by -2, it's the same thing as multiplying by -1/2. So it's going to be -1/2 times y minus 4. Now, rules for inequality still apply. Anytime you divide by a negative number, you need to change your sign. So instead of greater than or equal to, we actually are going to have less than or equal to x squared. Okay, so this is currently in the format that we need it to be in. So let's say the vertex of this parabola is going to be, there is no x movement, so it's just going to be down 4. So there's the vertex. To graph the focus, we need to figure out what p is. Well, we know that the coefficient of the non-squared term, -1/2, is 4p. So if 4p is -1/2, and we divide both sides by 4, then that implies that p is actually -1/8. So if p is -1/8, we find the focus of a parabola by h, k plus p. So it's going to be, we know that h is 0. We know that k is -4. No, k is +4. I had that wrong. I apologize, y'all. Since it's y minus 4, that means the vertex of our parabola needs to be up here at +4. Alright, hope I didn't freak you out too much earlier. +4, much better. Okay, plus p. So p is going to be -1/8. So 4 minus 1/8. Again, you need to be able to do this by hand. 4, if we multiply that by 8/8, is the same thing as 32/8. So when we subtract 32/8 minus 1/8, we get that the focus is 0, 31/8. So that focus is almost to 4, but not quite. So when you graph that point, just graph it real close, and always label your focus with an F. Okay, so there's the focus. We know the directrix is the same distance away, but on the other side. So we know that the directrix line is going to be 1/8 away on the other side of the vertex, and we know that the axis of symmetry is going to be here through the middle. Okay, so that's just also a good practice for graphing your parabolas. Now, this is y is greater than or equal to -2x² plus 4, which means our parabola is also going to be solid. And just estimate where the curve is, as long make sure your focus is inside. And then we're going to pick a test point for that as well. So I'm going to test 0, 0 because I can. So then I get 0 is greater than or equal to -2, 0 squared is just 0, plus 4. And I get 0 is greater than or equal to 4, which is false, which means I don't want to shade on top of 0, 0. I want to shade on the other side of the parabola, which is on the outside. So if I shade on the right side of the line, but on the outside of the parabola, then I'm going to get these areas that should be overlapped and shaded. Okay, last inequality to solve by graphing. Number 19, I've got 4y² plus 9x² is less than 144. Well, let's see, I've got, if you compare A and C, A is 4, C is 9. They are not the same, but they're both positive, which implies that this should be an ellipse. But we know that an ellipse should equal 1. So I need to go ahead and divide everything by 144. So let me do that to the side. So if I got 4y² plus 9x² is less than 144, in order for us to get this ellipse in standard form, I'm going to divide everything by 144. And when I do so, I'm going to get y² over 4 over 144 will reduce to 1 over 36, plus x² over 9 over 144 will reduce to 1/16 is less than 1. So now we're in business. Okay, so in order for me, since I'm using red for this ellipse already. I'm just going to keep it red. If I'm going to graph this ellipse, my y squared term is first, which means my ellipse is going to be stretched in the y direction. It is over 36, which means the radius in some case, I guess is a good way to say it, is going to be 6. So vertexes or center points at 0 because I don't have any h and k movement. So I've got 6 up and 6 down since that's the y direction, which of course is off the graph. Sorry about it. And then in the x direction, it's over 16, which the square root of that is 4. So now I've got 4 to the left and 4 to the right. So this is going to be a pretty big ellipse. It's just less than, which means this is going to have to be a curved, or a dotted curve rather, to graph this ellipse. So it should look something kind of like that. Okay, and then we're going to pick a test point. Again, I'm going to choose 0, 0 because I like it. So if I plug in 0, 0 squared over 36 plus 0 squared over 16 is just 0. Then I get 0 is less than 1, which is true. So if that's true, then I'm going to shade on the inside of that ellipse, eventually. Okay, next one is x squared plus 8y squared is less than 16. Well, again, if I look at A and C, A is 1 and C is 8, which means they're not equal, but they're both positive, so this is going to be an ellipse as well. Well, if I want this to be an ellipse, it also must equal 1. So I'm going to divide everything by 16. If I do so, then I have x squared over 16 plus y squared over 2, right? 1 over 8 over 16 is 2, is less than 16 over 16 is 1. So when I graph this ellipse in the x direction, again, its center point's also 0, 0. There's no h and k movement. Over 16 in the x direction, I'm going to go 4 and 4, which means it's going to overlap here to the left and to the right. In the y direction, b squared is 2. So the square root of 2 is like 1 point something. So I'm just going to go from, I'm going to go a little bit, so square 16, 4 square root of 2, a little bit over 1 in the y direction from that center point. This ellipse is also just less than, which means it should have a dashed curve. And it's going to fit perfectly inside of the other ellipse. I'm going to do a test point, also 0, 0. When I do that, I get 0 is less than 1, or if you do the original inequality, 0 is less than 16. Either way, this is true, which means we want to shade on top of that point, which is also on the inside of that ellipse. So if I'm going to shade on the inside of both ellipses, then the overlapping area will be here. Number 20 asks you to write the equation of a circle that passes through these 3 points and then determine the center and the radius of the circle. Note, you have to use a graphing calculator for this question. I know you won't get to use a graphing calculator for the test. Therefore, you can deduce that one will not be on the test. But for the sake of just practicing what we've learned through the chapter, it's on your study guide. Okay, the thing to remember about a circle is that the general equation of a circle has the equation x squared plus y squared, right? A and c are both equal to 1. So x squared plus y squared plus dx plus ey plus f is equal to 0. So what we're going to do is we're going to take the 3 points that were given to us and substitute those values into this general equation. So if I substitute in an x of 0 and a y of -1, that implies I'm going to get 0 squared plus -1 squared plus d times 0 plus e times -1 plus f is equal to 0. If I substitute in the point 2, -3, everywhere I see an x, I'm plugging in 2, so that's going to be 2 squared plus -3 squared plus d times 2 plus e times -3 plus f equals 0. And then the last point, 4, negative 1. If I substitute that in, I get 4 squared plus negative 1 squared plus d times 4 plus e times negative 1 plus f is equal to 0. And then you're going to simplify these three equations. So if you simplify, 0 squared is 0, negative 1 squared is 1. If I move that constant to the right side of the equation, essentially what you want all of your equations to be in line with d, e, f equals your constant. So if you simplify this system of equations to do that, then you're going to get 0 times d, which you could just leave as, you don't even have to write it if you want, but you'll see why I'm going to write it in a second, minus e plus f equals negative 1. Then 2d minus 3e plus f equals negative 13. And then 4d minus e plus f equals negative 17. And then what you're going to do is you're going to take these coefficients and you're going to plug them in the calculator into the matrix function in your calculator. So if you open up matrix, hit second matrix, scroll over to edit, you're going to input your rows and columns. So you're going to have 3 rows by 4 columns. And you're going to put all the coefficients for this system of 3 equations that you have here. So coefficient for D, E, F, and then your constant. So this isn't for us, it'll be 1, negative 1, 1, negative 1. 2, negative 3, 1, negative 13. 4, negative 1. This should have been just plus F. Okay, so that's a positive 1 minus 17. And then you're going to exit all of that, and then you'll go back to your home screen, and then you take the reduced row echelon form, or RREF, of the matrix, and then you're going to end up with the identity matrix. So the identity matrix looks like this. And then the 3 numbers in your last column, negative 4, 2, 1, those are the coefficients for D, E, and F. So that means you can go back to your original general equation and substitute those values in for D, E, and F. So if I do that, I've got x squared plus y squared plus D is negative 4x plus E is 2y, and then F is 1, so plus 1 is equal to 0. And then this is your circle. So your job, in order to find the center and the radius, is we want to move things around and complete the square twice so that we get it into the standard form that we need. So if I group my x's, I've got x squared minus 4x. I'm going to leave a room for plus a new c, plus y squared plus 2y plus a new c for the y's is equal to negative 1. And then so we're going to complete the square twice. So for the x's, it'll be negative 4 over 2 squared, which is equal to negative 2 over 2, or negative 2 squared, which is positive 4. So if I add 4 there, I'm going to add 4 to the right-hand side. For the y's, b over 2 will be 2 over 2 squared, which is 1 squared, which is 1. So if I add 1 to the left side, I'm going to add 1 to the right side. When I do that, my trinomials can be rewritten as x minus 2 squared plus y plus 1 squared is equal to negative 1 plus 4 plus 1 is 4. So this is the equation of a circle that passes through those points. From this, we can gain that the center is positive 2, negative 1, and that it has a radius of 2. For questions 21 and 22, write the equation of an ellipse given the following. So an ellipse, we have both x squared and y squared are going to be positive, and it must equal 1. E in this case stands for eccentricity. Now, eccentricity, we've learned, is equal to c over a, but sometimes that might be the reduced form of eccentricity. So basically, anytime you have your eccentricity questions, you want to gather as much information you can from the other stuff before you look at eccentricity. Okay, here's how. First of all, it's good to get an idea of the locations of these foci so that we understand the shape of our ellipse and if the x squared term or the y squared term should come first. So if I graph these foci, if you imagine the foci at -5, so if you go -5 to the left and then 4 down, and then the other foci would be -5 and then down to -10, like this. That means they have the same x values and different y values. That means our ellipse has this orientation that's stretched more vertically, which means our y squared term is going to be first for number 21. Okay, if your y squared term is first, if you look at like all of our information for the equations of an ellipse, the foci are found by h, comma, k plus or minus c. Same thing for this one, h, k plus or minus c. So from this, we know that h is -5, right? And then we have to figure out what k and c are. So if we know that, let's say, okay, if we know that k plus c is equal to -4 from the first focus, and that k minus c is equal to -10, oops, k minus c is equal to -10, then we can solve the system of equations. If we add them together, c minus c is 0, k plus k is 2k, equals -14. So if we divide both sides by 2, that must mean that k is equal to -7. So if that's the case, then we know our center point, hk, again, we know h is the same in both of the foci, so h is -5. So -5, and then k must be -7. Well, to graph an ellipse, or to write the equation of ellipse, we need h, we need k, and then we need a and b. Well, I have h and k, and again, I need to use my eccentricity somehow. Well, if I have eccentricity, well, let's see. Let's go back to our focus. If I know that -4 is k plus or minus c, so let's see, k plus c is equal to -4, but we just found that k is -5. So if I substitute that in, then -5 plus c is equal to -4. If I add 5 to both sides, no, that's not right. Oh no, I'm sorry, k is -7. There we go. Okay, so if I add k plus c, this is what I'm looking at. K plus c is equal to -4. We just found that k was -7. So -7 plus c is -4. If I add -7, or if I add 7 to both sides, then I get c is equal to 3. So then if I look at my eccentricity, which is 3 over 5, if the eccentricity is 3 over 5, and I've just solved for c is equal to 3, then that implies that that definitely must be c over a, because you just solved that c was equal to 3, which implies that 5 must be a also. So if once you found c is equal to 3, that must imply that a has to equal 5. In an ellipse, I'm running out of colors here, we know that the relationship between a, b, and c is c squared is equal to a squared minus b squared, because we know a has to be bigger than b. So if I know c is 3, then 3 squared is equal to a squared is going to be 5. So that would be 5 squared minus b squared. So then if I isolate b, I'm going to get 9 equals 25 minus b squared. So if I subtract 25 minus 9, move b to the other side, I get 16. So b is going to equal plus or minus the square root of 16, which is 4. And that's all I need to write my equation. I have h, k, a, and b. So my final answer will end up being, again, my y squared term has to be first, which we found at the beginning. So when I do y minus k, it's actually going to be y plus 7 squared over a squared is always first. So 5 squared is 25. It's an ellipse, so I have a plus sign. X minus h will be x plus 5 squared over b squared is always second. If b is plus or minus 4, when I square either one of them, I get 16, and that's equal to 1. Okay, number 2. 22, sorry, the eccentricity of this ellipse is 3 square roots of 14 over 14. And the focus is 6, 10 plus or minus 3 square roots of 5. So again, you always want to save your eccentricity for last. I would also go ahead and estimate where these foci are to get an idea of, is my x squared term first or is my y squared term first? Well, if I've got 6, 10 plus or minus 3 square roots of 5, that means from the origin you're going to go 6 to the right, and then for one of them we're going to go 10 plus 3 square roots of 5, and the other one you're going to go 10 minus 3 square roots of 5. So that's also going to be a y squared first ellipse. The other thing is, notice h is by itself. It's the k that we're having the plus or minus c at. Okay? And so if you line it up this way, if you look at your chart, you know that your ellipse only has h comma k plus or minus c if the y squared term is first. So if you do this, then you know a lot of information off the bat. You know h and k must be 6, 10, and you know that c must be plus or minus 3 square roots of 5. So that's great. All we need to find is a and b, and we know that we're going to find a and b from c. We're also going to find a and b using the eccentricity. Okay, we know that eccentricity is equal to c over a. Well, you just found c, and they gave us e. So we're going to substitute those values into this equation. So instead of e equals c over a, we're going to plug in 3 square roots of 14 over 14 equals c, we said was 3 square roots of 5 over a. And then our job is to actually solve for a. So I'm going to go ahead and cross multiply here. So if I do that, I'm going to get, let's see, 3a square roots of 14 is equal to 3 times 14 is 42 square roots of 5. And then our goal is to try to get a by itself. So let's see, I can divide both sides by 3. And then I get a square roots of 14 is equal to 14 square roots of 5. If I'm trying to get a alone, I'm going to divide both sides by square root of 14 now. And then I get a is equal to 14 square roots of 5 over the square root of 14, which I totally cannot leave this like that. I need to go ahead and rationalize this. So if I'm going to rationalize this, I'm going to multiply this by the square root of 14 over the square root of 14. And in doing so, let me move back up here, keep running out of room. I get a is equal to, when I multiply straight across, 14 times the square root of 5 times the square root of 14. Rules, we can multiply the stuff on the inside together. That's going to be square root of 70. Over square root of 14 times square root of 14 is just 14. And then 14 over 14 is 1, leaving us with a is equal to the square root of 70. So I found a, and I already knew c, and I knew h and k, so now I just got to go find b. Well, again, we know the relationship in an ellipse is c squared equals a squared minus b squared. So if I know that c is 3 square roots of 5 squared equals a squared, so that'll be the square root of 70 squared minus b squared. Well, 3 square roots of 5 squared. 3 squared is 9. The square root of 5 squared is just 5, so that'll be 9 times 5, equals the square root of 70 squared is 70 minus b squared. Okay, 9 times 5 is 45. Then when you subtract 45 from 70, you get 25. You move that b squared to the other side. You end up with b squared is equal to 25, which implies that b is plus or minus 5, which is a lovely number. And there's the missing piece. You need a and b and h and k, which you have. So your final answer, again, we know that our y squared term must be first. So we're going to have y minus k, which would be y minus 10, squared over a squared is always first. So the square root of 70 squared is 70. An ellipse has a plus sign, times x minus h, which will be x minus 6 squared, over b squared. B is 5, so it'll be 25 is equal to 1. Okay, 23 and 24 are very similar to this question, except these are going to give us equations of hyperbolas, but still dealing with eccentricity. So for number 23, they give us a center point, 2 and 3, which is great, because that's already half the battle there. That's h and k. And then we know we have our focus, and we have eccentricity, so square root of 89 over 5. So the thing with the hyperbola, again, before you even really start working too much, I would look at the information I'm given, and I would figure out where the orientation of this hyperbola is to know, is the curve up and downward, or are the curves to the left and to the right, letting us know which x or y is actually going to be squared. So if I've got my center point at 2, 3, so let's say that that's about here somewhere, then the focus is going to be at 2, 3 plus or minus square root of 89. So it has the same x value. And then from there, it's going to be 3 plus the square root of 89, so something like this. And then maybe 3 minus the square root of 89, something like that. So again, in order for that to occur, the curve has to flip up and down like this, which means the y squared term must be first. Okay, so I know h and k have to be 2 and 3. I know if the y squared term is first, and if I'm looking at all of my equations for the hyperbolas, I know the foci are found by h, k plus or minus c. Well, we know h is 2 already, and we know k is 3 already, which implies that c must be the square root of 89. So if the c is the square root of 89, I need a and b in order to write the equation of this ellipse. I don't have any other information, so I have to go to eccentricity now. Eccentricity is given by c over a, but I've claimed, I know for a fact, that c is the square root of 89. So if c is the square root of 89, then that must claim that a is also equal to 5. So then if I do my relationship in a hyperbola of a, b, and c, c squared is equal to a squared plus b squared. So then that'll be the square root of 89 squared is equal to a squared will be 5 squared plus b squared. Well, the square root of 89 squared is just 89 equals 25 plus b squared. If I subtract 25 from both sides, I get 64. So b will equal plus or minus the square root of 64, which is going to be plus or minus 8. So this hyperbola, I know the y squared term must come first. So I'm going to do y minus k, which would be y minus 3 squared over a squared is always first. Even though it's not necessarily bigger in a hyperbola, a squared is always the first denominator, so 5 squared is 25. The hyperbola has a minus sign in between our fractions, so x minus h will be x minus 2 squared over b squared will be 8 squared, which is 64. That is equal to 1. Okay, last one like this, number 24. The center point is 6, 7. So again, that's half the battle. I already gave you h and k. The focus is 6, 7 plus or minus 2 square roots of 13. Well, this is similar to the last one. This focus is going to be h, k plus or minus c. So h is 6, we already knew that. K is 7, we already knew that. But this implies that c is equal to 2 square roots of 13. So even though eccentricity is c over a, again, you have to remember that may have been reduced. So what this means is this eccentricity, square root of 13, is not c, and 2 is not a. Because given from the focus, c is 2 square roots of 13. Okay? But if we know that eccentricity is equal to c over a, then I can substitute this value in for e and this value in for c, and I can solve for a. So let's do that. Instead of e equals eccentricity, I know is the square root of 13 over 2 equals c is 2 square roots of 13 over a, and I don't know what a is, and that's what we're solving for. So if I cross multiply, I get a square roots of 13 equals 2 times 2 is 4 square roots of 13. In order for these two to equal each other, that must imply that a must equal 4. So you've got a, you already have h and k. The next thing we need to find is c. I'm sorry, b. We already know c. So if c squared is equal to a squared plus b squared, c is 2 square roots of 13 squared is equal to 4 squared plus b squared. 2 square roots of 13 squared. 2 squared is 4. Square root of 13 squared is going to be 13. So it'll be 4 times 13 equals 4 squared is 16 plus b squared. 4 times 13 minus 16 will end up being 36. So then b is going to equal plus or minus the square root of 36, which is 6. So now you have b. So you have a and b, and you have h and k from the get-go. Again, because this one's the same setup as the last, hyperbolas that have foci that are h comma k plus or minus c imply that the y squared term needs to be first. So again, we're going to have y minus k, which would be y minus 7 squared over a squared, which is 4 squared, which is 16. Hyperbolas have a minus sign, times x minus h will be x minus 6 squared, over b squared will be 6 squared, which will be 36, is equal to 1. And there's the equation of your hyperbola.